So first of all, what is MQTT? MQTT protocol is an extremely lightweight and efficient publish, subscribe messaging transport that is ideal for connecting industrial devices to the cloud. It requires minimal network bandwidth. MQTT allows for messaging between device and cloud to device. It's easy broadcasting messages to a group of things, and it's very secure as the message encrypts. And I will go over the next slide what I mean by secure. So how does publish, subscribe, and broker work? First of all, you have a client, and then you have a broker. The brokers are basically a server. I will discuss this broker in a consequence slices, but right now let's just focus on, let's say we have a client device, and this client will publish the information to the broker. So when you publish something, you have a topic. So what topic are you publishing? Within that topic, there is contents of the topic, or we refer to as payload. So the payload for that topic could be a temperature, could be pressures. A second topic would be I have Sunnyvale /alarm, machine A /alarms, and then the actual content or the payload would be high pressure and the actual pressure of that machine. Okay, so that's how a client publish to the broker. And then you have a different client, and this client would be basically subscribing it to that topic. For example, if this client right here I have, this client subscribed to this topic Sunnyvale /machine A /status. So when this client publishes this information, and this client on this side subscribing to that topic, then you will get the content, or basically the payload in there. So you get temperatures, you get pressure, and so forth. You could have another client publish to, let's say, the second topic, Sunnyvale /machine A /alarms. So when this client subscribes to it, you get this high pressures, the actual values of it. Okay. So what is considered a client? A client can be a PLC, it can be an HMI, it could be your mobile devices, could be your tablet, could be your laptop, your phone, or it could be your iWatch. So that's an example. Now, as you can see, the broker is basically the middleman doing everything. When a client, such as your iPhone, trying to get information from this PLC over here, typically you would have to pinpoint the PLC IP address. In this case, there's security involved because you're basically exposing the client IP address. But not in the case of MQTT, that's not the case. You're just basically subscribing into the topic. So even though you're trying to get information, this client trying to get this information to this client, because it's subscribed to topics, and you're not exposing any IP address here. So it's considered a very secure protocol. Okay, so that's how publish, subscribe, and broker work in top level overview. Now, the next question is, how many clients can I have? Basically, I don't think there is a limitation here. You could have as many clients as you want. Okay, there is no limit in terms of number of clients. And a client can publish and subscribe simultaneously. This is basically bi-directional. An example would be my FC6A PLC can publish information and can subscribe information at the same time. So that's how publish and subscribe works. Okay, so now that we've defined what is a client, let's go into what is considered an MQTT broker. For our definition, a broker can be a private or local brokers, and there's a pro and cons to this. when you create your own, or basically your local MQTT brokers, usually people would run this Mosquito software platform in here. Okay, so you could create your own server MQTT brokers. The pro for doing your own is that there is no subscription fees, so you're not paying anything for accessing it. But the con is basically there's maintenance issue. It's difficult to implement. At least it's more difficult than if you go with the cloud platform. There's security involved. Of course, people can hack your brokers or your server. And then there's limited third-party integration involved. And I will discuss what do I mean by third-party integration, okay? So the first option is you build your own MQTT server or MQTT broker, okay, doing this configuration. But this is not our main focus. Our main focus for today is the public, which is the cloud platform. Now, using the cloud platform, there's more pros than cons. The pro is that there's no maintenance basically. Okay, everything is maintained by the cloud. It's actually very low cost, easy to deploy. It's very secure. Like I explained in the beginning, you access using topic, so your device is not exposed. Third-party integration is widely available. Okay. And of course, the cons is that you have to pay subscription fees, but it's very minimal. I will explain how much it will cost if you sign up for, let's say, AWS account. Okay. So this is our main focus for today is how to configure our PLC to talk to one of the cloud platforms here. Okay. So this will be our main focus. So now, if let's say you have a bunch of clients or multiple systems deployed, and you publish this information to the cloud. In this case, we will choose Amazon Web Services, AWS. So if you're able to choose your device is publishing all this raw data, I consider this raw data. You have temperature, you have pressure, you have log data, all that information, you have it in the cloud. So what do you do with it? I mean, you have all this information. So what do you do? There are a lot of third-party integration available, and I'm just naming some of them here that allows you to build a custom interface. Or in this case, we call it a dashboard. Right? So things like there's third-party integration like Thingsboard, there's AWS Lambda, there's Grafana, and Comprosys, GNX. So these are some of the third-party integration that we have started playing with and tested. And I maybe in the next month or so I can show you some of this how it works. So basically, if you use this third-party integration, you can actually create a dashboard, a very nice interface dashboard. You can do this type of dashboard, or you can actually interface directly. Let's say if you have a Google spreadsheet, you basically send information directly to the Google spreadsheet to keep the logs of everything. Okay, as simple as that. So once you have your PLC, your system deploy and publish information to AWS brokers, your other devices of your phone, your tablets, your computer, you have access to everything once the data is in the cloud. So that's how it works. So what is the benefits of having all of this? So as you know, nowadays everything is data driven. Once you have the data, you're the king. Even basketball nowadays, even baseball, everything is using data for analytics, right? Once you have the data, you can analyze anything you want. You could do predictive maintenance. Basically, it's controls at your fingertip. You can do anything you want with your system that you deploy. Visualization, like I said, you could create a dashboard. You could have an alarms and notification. So there's basically endless possibilities. Once a system is deployed and subscribe and publish information to the cloud, you can do all this stuff. So this is the reason why we call this MQTT protocol is the IIoT protocol, Industrial Internet of Things protocol, because you are basically it allows you to easily get information. Once you have that data, you can do analytics, you can do a lot of stuff. Okay. This slide is basically, I just want to show you the different, I think most of you know already, but I just want to make sure that you understand the difference between MQTT protocol versus other industrial protocols, such as Modbus TCP, such as Ethernet IP, CAN J1949, BACnet, and so forth. So on this left-hand side is basically industrial protocol. So industrial protocol, you have a VFD, you could have remote I/O, you can have switches and sensors talking Ethernet IP or talking Modbus TCP to our FC6A PLC. And then you could publish this information and send all that information to the cloud using MQTT protocol. Once the information is on the cloud, you have access to everything. It's built a SCADA system. You can have your phone accessing all that information down to the field devices level. So basically, you have your client here can have access to your VFD. Okay. So for a simple illustration or application example, I picked a microbrewery. Right. So I put single location. Let's say you have a location that make beers. I'm not sure if you guys are aware, but in brewery applications, there are many processes to it, right? And each process is controlled by a single PLC or a single controller. Like the crushing system will have its own PLC, the filtration system will have its own, cooling, fermentation. Each process has its controller controlling that process. And controller to controller communication is very critical, because to go from one process to another, this PLC will need to be able to tell that PLC, okay, get ready, I'm done with my process, let's start with the next process. So that's why controller to controller communication is very critical in this type of process. So you break it down further. Let's say for crushing system, you have flow, you have RTD, you have remote I/O example talking to your system, right? And this system could be using Modbus, it could be using standard digital I/O or Ethernet IP. So most of the time, you would use Modbus, Ethernet IP, or industrial protocol to talk to the PLC this way. I don't think you will use MQTT for this purpose, nor because each process needs to be able to communicate to each other. Again, most of the time, or majority of the time, you would use Ethernet IP or use Modbus TCP to communicate between devices at this level. Even though MQTT allows you to do device-to-device communication, but I don't anticipate this will be the case. We're still going to be using Ethernet IP and Modbus TCP for this instead of MQTT. So now that your system, let's say your system is working and talking to each other over devices, the next thing is, okay, I want to be able to get all that data, my flow data, my RTD data, all of my communication data to the cloud. Using MQTT, if our FC6A is equipped with MQTT, all that information can be published to the cloud. And as most of you knows right now, once that information is on the cloud, you have full access to all the data available. Right? You could be at home using your phone and checking all the status. You could be on vacations. You could be actually at the local plant and be able to have access to all the information available to you. So that's the reason why MQTT is called the IIoT protocol. Now, for multiple locations, let's say you have a brewery in San Diego, you have another brewery in Portland, you have another one in Japan, right? Now, if because of MQTT and now FC6A allows you to talk to the cloud, you can put all of that information to the cloud and do the same thing. Have access to every data for every location that you deploy. So instead of microbrewery, this could be a oil and gas application, right? It could be a system that you deploy all over the world, and you'll be able to access to everything out there. This next slide is basically how we support MQTT. MQTT is support on Ethernet port 1 of the FC6A Plus CPU. Again, it's only available in FC6A Plus CPU, not available in the all-in-one. It will be available as a firmware upgrade. There is no additional cost. There is no additional hardware. The existing system or FC6A PLC that our customers already deploy in the fields can be upgraded to support MQTT. The firmware is available in AO version 3.21 or later. Basically, it's one letter 8.17.0. Right now, we're targeting to release AO 3.210 in the next 2 weeks. Okay, so that's our current plan right now, is to release this MQTT in 2 weeks. As the first phase rollout, we will only support Amazon Web Service IoT Core. Okay, we cannot say just AWS because AWS itself has a lot of services, and I will show you later on what I mean by that. So the specific service that we will support is called IoT Core. So this is basically for IoT devices. Okay, so right now we only support AWS. Future support, so as we're still planning or in the work to make sure that we can support Microsoft Azure and also Google Cloud. Okay, so future support will be for Microsoft and Google. Right now, AWS only. I would encourage you, if you guys want to test MQTT features, Elias, Britt, myself, we could assign you an account, but it's actually pretty easy if you want to sign up for your own account and you can keep track of everything. If you want to sign up for an AWS account, just go to this URL, and it only requires a credit card. Okay, so you have to put in your credit card information. And this one will be basically showing you the actual cost on how much it will cost for you to use this services. Okay, so there's two parts of this. There is a connectivity part and there is a messaging part. And it will give you a pricing overview. If you look at the connectivity alone, it will cost you roughly about 4 cents a year for one device. If you have it connected 365 days, 24 hours, 7 days, 24 hours a day. So basically 4 cents a year for one device if you had it on 365 days. Okay, and then the second part of the messaging is basically the actual message itself. The actual message itself, it will cost you $1 per million messages. If we use this account for testing purpose, I don't anticipate that you will get any charges. Because if it's less than $1, basically less than 1 million messages, Amazon not going to bill you for it. So basically you can sign up, put in your credit card, and you have access, and then you could do any testing you want. Okay, so that's basically the end of my part 1 presentation.